So the group 2 are going to talk about oceanic oscillations and the Congo River Basin climatology. And in this group, we've got James, Magda, Rajiv, Jeffrey, Pratik, Lorenzo, and Masuma. And I believe Rajiv is presenting. Is that correct?
Yes, I'm the only one here.
Okay. Welcome. And thank you for coming.
Yep.
So if you want to share your screen and then present, that would be great.
Can you see the screen? Okay, thank
Yeah,
you
we see
very
that.
much. Yeah, thank you very much for giving opportunity to present our work. At the start, we were 5 or 6%, but in the end, I'm the left alone. The person who did, he's not available. He has some issues, so he could not come and ask me to present us our work to this year. So we worked on oceanic oscillation and on Congo River Basin climatology. So I'm going to present our what we work, why we work this oceanic oscillation and Congo River Basin, what data we use, methods and results, and the possible conclusion that we did. So as we know already, the climate change is happening. According to IPCC, the latest report is the temperature is going to increase more than the 4 degrees Celsius, and that has been impact on not only the human life, also the food production system. While the food production is a major thing, if you don't have food, you cannot survive. But the food system is depend on the hydrology, on the atmosphere, and the drought, especially the drought index, drought. But those things all depend on the oceanic movement or SST, sea surface temperature. That we have already noticed, the sea surface temperature is rising from 1882 to 2020, with the most rapid increase occurring in the last 3 decades. However, the ocean has the major role in heat absorbing, releasing water vapor, managing the hydrology and those rainfall precipitation. Those things are happening. Even the drought can be occur if the surface temperature will increase more. So the data set we use. Our study region was Congo River Basin, and we got the save file from the Rafael and Thasimanga that the James one of our joint person, he communicated with them, and personally he got the save file for that reason, and we use this save file to extract the sea surface temperature data from this save file. Also, we have did rainfall variability. We use CHIPS dataset and NDVI too. We use this shape file to mask the data from the NOAA mean SST dataset for full set of years from 1981 to 2023. Then we identifies multiple oceanic dipoles and indices like Indian Ocean Dipole, Southern Atlantic Ocean Dipole, and many more. We try to do it by ourselves. We work all those things on climate tech also platform we use, and we also try to what we have learned during the summer course, the Python libraries and X-ray and Panda. We try to utilize those things. So this is the methodology why we done this SST on what is the impact. In previous work, we have already done the changes in rainfalls during the summer course, and we found out the variability in the rainfall was not directly affected by the vegetation, like deforestation. The deforestation is more in Congo River Basin, but there was no direct relation with the rainfall and the vegetation. However, changing vegetation make increase the crop production. As you see, the latest data set for the land use, the crop production has been increased, but the rainfall relationship we could not find it directly. So we tried to check this rainfall variability with the oceanic movement, like not oceanic oscillation, like El Nino South El Nino ocean oscillation and these other indices. So this is the one results we have plotted from 1981 to 2023. And then in the end of the period, you may see the heat is going to increase, like the sea surface temperature. This one was the observed from the Indian Ocean dipole anomalies for the period this. The second indices was Atlantic Nino, that for the same period, and in the end, if you see the sea surface temperature is going to be increased more and more. And the third one, I cannot see because of the heading. South, I think it is a south something. Okay, and the last one was the tropical Atlantic dipole anomalies. That in the last figure, you may see the red color is occurring more in the eastern side. That's surface temperature, sea surface temperature in eastern tropical North Atlantic oceans. So based on these results, we find out that SST has been shown to influence Congo River Basin precipitation with the tropical Atlantic, and a positive phase of Indian Ocean dipole involves warmer than normal western equatorial tropical Indian SST that caused the most drought period and the heat period more, while the cooler period will be there in eastern Indian Ocean near to Java and Sumatra. Further, the positive Indian Ocean dipole often brings more floods because of the heavy water evaporation from the ocean to East Africa zone, not in the southern part, while bringing drought in Eastern Asia and Australia. Another is the positive effect of this in the rainfall, which affect the Congo River discharge, and alternately Eastern tropical Atlantic salinity. So we can suggest, with this result, we can suggest for the further exploration of oceanic oscillation teleconnections may help develop a better understanding of Congo River Basin climatology. So this one was the conclusion. Post climate change driving increasing ocean temperatures globally, sea surface is also continuously changing with these oceanic oscillation indices. Dipoles are diverse, not linearly related with global sea surface temperature that we have seen, but increasing evaporation and temperature across ocean basin that may cause to extreme event like heavy precipitation or drought condition too. So this much result, I'm sorry, our results is not too big. As I said earlier, we started with the 5 group, but later we were become 2%, and then in the end, only 1% I left. So we could not manage to finish our work. However, one person had decided to extend our work, but he will do, I think, by himself, and he would be alone on the evapotranspiration to calculate those values, effect of the latent heat and evapotranspiration on the Congo River Basin, that why this rainfall variability is happening more in that region. Yeah. Thanks for this.
Thank you very much, Rajiv. Thanks for taking the time to present to us. So yeah, it's very interesting that perhaps your group had a very different experience to the previous group, and you know, I guess from from the experience for the scholars program, it'd be good to understand if that was if there was something that could change. So if I'm not expecting you to have to answer that now, but you know, it's always good to
Yeah, the problem was the group. Yeah, you know, everyone is working, and when we started writing proposal, okay, we will do, and then one person, Mosemi, then Lorenzo, he got the job, he shifted somewhere else. Then Pratik left. Then yeah, we suffered a lot with this
Yeah,
5 months.
it's yes, and of course you're all doing it as volunteers, but even so, what you've done is really great. So
Yeah, that was my thought. If we have done something, we must report what we have done. It's not
yeah.
about
So
the
it's
just left everything. That's why
so
I
do you
I came out. Yeah.
so my question is, I mean, it's great you've put together some nice data sets for the Congo River Basin and looked at the dipoles in the SSTs. And so with the Indian Ocean dipole, did you, I mean, you know, it's great that you made that statistical connection, and I just wondered if in the group you'd thought about the mechanisms or whether that would be something
It
that
was,
people would look
yeah,
at.
mechanism. We wanted to see how it is affecting the rainfall variability to, you know, by the sea surface temperature. We could not do the more statistical analysis because of the workforce, work people, they were not available. Yeah.
I had
I'm sorry for that.
Yeah, Julie.
Yeah, well, thank you for coming today and presenting, because it's great to see what you had achieved, and I think even just, you know, getting familiar with Python and these data sets is useful, right? Even if this is where it ends. But I'm interested in why you decided on the Congo River Basin, and was there so I couldn't quite see the label bar on the rainfall plot, but has there been an increase in rainfall in that region and over this time period that you were
The
looking
first
at?
question, well, you ask about why we choose Congo. Actually, we choose is because of the forestation. You know, the Congo River Basin has a lot of forestation after the Amazon. So we choose it for the larger region. The second is it affected by both sides from the Oceanic.
Right, it's in the middle.
Okay.
Yeah.
So we do in coursework, we have already done the rainfall variability. We found it that rainfall is changing, but we could not find the good correlation with the NDVI. We cannot say, okay, maybe deforestation is occurring and rainfall is changing, but we could not find the good relationship. So we decided, okay, let's check with by the sea surface temperature, how it is happening, ENSO, El Nino, South Oscillation, and other those indices, Indian Ocean Dipole. So we tried to started with, well, yeah, but something we got only, I can say, not that too much. As you have seen, these results is just a plot of those data sets.
Yeah,
If we could do some statistical analysis, we can say.
no, thank you. Yeah, I think it's looks intriguing, and yeah, you've done well. I see another question from Ray.
Yes, I was just wondering, this comparison, I found the comparison between your deforestation and rainfall quite interesting. So I was just wondering, did you carry out this comparison on a pixel to pixel basis? As in, at the same pixel, did you check the change in vegetation and rainfall? Because in my understanding, I mean, I don't understand rainfall a lot, but in my understanding, the change of vegetation in one place can affect the rainfall in another place as well. So did you account for that?
That's not the place we took the data set from the NDVI. Yeah, pixel to pixel. Yes, the chip
Okay.
data set. We also, yeah. one by one, we select those area and we compare with the precipitation. Then we decided not to annually, we converted in 3 month season, like October to December, then winter period, then summer period, which would, but pixel to pixel, yeah.
It's very interesting work, and if you want to collaborate.
Work was interesting, yeah,
I'm available.
really work was interesting, but this is the group work and those things we suffered. I'm very glad to see you. Your group was fantastic. 5 people were continuously, but we could not manage. Some problem occurs with among us. Yeah. There was some family issue with James, and he was completely frustrated during December. And one person got the news job, he left. He did not respond to it. And
But
another
it's great,
person,
you know, you've
yeah.
you've taken some of the skills that you learned on the course with Python,
That
as
was the
Julie
main
said,
objective, yeah.
and you've been able to use those in a kind of real situation, and you know, not every project will come to the same position, and you know, and that's the life of research as well. So that's you know, quite normal. So have we got any other questions? Okay, well, if we have no other questions, then it just leaves me to thank Rajiv for the presentation, to thank both of and also Group 1. I think Rika's going to say something about Climatematch Academy, and then we'll have the group photo, and I and hopefully Julie will be able to stay around with others for a bit of networking.